All right, what's going on, class of 2022? Today is Monday, April 28th, and we're going to continue our notes. Topic today is parallel and perpendicular lines, as well as triangles, and this is going to be page 52 in your notes. And a couple symbols I'm going to put up there at the top just to help us remember. Parallel, as we'll see, are two lines that will never ever meet. And then perpendicular lines are two lines that meet and form 90-degree angles, which would look like that. So go ahead and copy down the definitions for parallel lines. Again, two lines in a plane that never meets. Perpendicular lines are two lines that cross and intersect at 90-degree angles. And then the transversal is a line that intersects any two or more lines. So what I'm going to do is, in blue, draw two parallel lines. Again, they would go on forever in both directions and never ever meet. And then in the red marker, I'm going to go ahead and draw a transversal line, which is a line that intersects two or more lines. And in this case, the transversal crosses and makes 90-degree angles. So therefore, the transversal forms perpendicular lines with the parallel lines when it crosses in that manner. What I'm going to do over here is draw two more parallel lines. But in this case, the transversal is going to intersect at an angle, thus forming other angles. Alright, so what I'm going to do is go ahead and number our angles. Doesn't matter how we number these. I'm going to call that one angle 1, angle 2 there, angle 3, angle 4. This one's going to be 5. This one's angle 6. This one's going to be 7 and 8. So there I have 8 angles that were formed by the transversal. If you look below, there are angles that form alternate interior angles, and there are angles that form alternate exterior angles. So in this case, with the green arrow, I'm going to show you all of the interior angles, all the ones inside of the parallel lines. Then in red, I'll draw arrows to all of the exterior angles, the ones outside of the parallel lines. So, if we had to list the alternate interior angles, that would be angle 3 and angle 6, as well as angles 4 and 5. Our exterior angles are 1 and 2 and 7 and 8. And then corresponding angles are angles that are equal, and in this case, the angles that are even are, or that are equal, are 1 and 4, 5 and 8, all of those are equal. And then 2, 3, 6, and 7 all correspond and are equal to each other. Alright, go ahead and copy down the properties of transversals to parallel lines. And basically saying that if two parallel lines are intersected by a transversal, as was the case that we just did, all of the acute angles, so all of the ones that are less than 90 degrees, are all congruent or equal. All the obtuse angles, the ones that are all greater than 90, those are all equal to each other or congruent. And any acute angle is supplementary to any obtuse angle. So basically when you add the acute angle and the obtuse angle, since they're supplementary, that means they add up to 180 degrees. Alright, so that's the majority of the notes that we're going to take. I'm going to flip over to the next page. We're going to do some practice problems together. I think this will make more sense. And then we'll talk a little bit about triangles, and you guys will be on your way. All right, so go ahead and copy down these instructions at the top that say to classify each pair of angles in the figure to the right as either alternate interior, alternate exterior, or corresponding. And we went ahead and listed the definitions for each of those on the page before this. So question 1 wants us to classify angles 1, which is this angle here, and angle 7, which is there. I can go ahead and see that both angles are outside of the parallel line, so that's going to make them exterior. And in this case, they're going to be alternate exterior. All right, angles 2 and angle 6. I'm going to go ahead and circle. So angle 2 and angle 6. One is exterior, one is interior, so we can't label them that way. So actually angles 2 and 6 are the same, so those would be corresponding angles. And then question 3 asks, if you got it, go ahead and classify the relationship between angle 4 and angle 6. I'll give you a couple seconds to think about it and see which one you think that is. So here is angle 4, and there's angle 6. Look to see if those angles are inside or outside the parallel lines. In this case, they're inside, and they are alternate interior angles. All right, let's go ahead and scroll down to this practice problem where furniture designer built the bookcase shown. All you have to do is copy down the lines that are in the bookcase. I shouldn't use the same color, so copy down that parallel line and that one. Have it being intersected by the transversal, and then you can see your angles 1, 2, 3, 4, 5, 6, 7, and 8. And they're telling us that angle 2 here is 105 degrees, and we have to find angle 6 and angle 3 measurements. All right, so angle 2 is supplementary to angle 6, which is right next to it there, which means total those angles add up to 180. If angle 2 is 105, you guessed it, angle 6 would be 75 degrees. And then if we had to find angle 3, angle 3 is an interior alternate angle to angle 6, which means that they are equal, 6 and 3, so that means angle 3 is 75 degrees as well. Go ahead and refer to those lines and find the measurement of angle 4, and we'll check in with you tomorrow to see how you did with that one. All right, I'm going to go ahead and flip to the next page where we're going to talk about triangles and the triangle sum theorem. So go ahead and copy that down. We're going to draw 2 triangles here. And we know that a triangle has 180 degrees in it. So if you were to get a problem that said, hey, here's an angle of 50 degrees, here's an angle of 60 degrees, find x, well, you would take 50 plus 60 plus x, and that equals 180. When you go ahead and solve for x, you get 70 degrees. As you see below, degrees can either be in numbers like we just did, or they can be in variables. So they might say here is a degrees, here is 2a degrees, here is 3a degrees. Find the value of a. Well, we know that if we add all of the angles, they total up to 180 degrees. which means we then have 6a equals 180, each a equals 30. So if they ask you for what is a, then a is 30. They may ask you to go ahead and plug in a and tell us all the values of the angles. So a here makes it 30. 2 times a would make this one 60. 3 times a would make that one 90 degrees. All right. All right, so the last part of the notes is to copy down the definitions for the following triangles. Here you have an acute triangle, where all the angles are acute or less than 90. Then you have a right triangle where it has one right angle. And then you can have your obtuse triangle here because one of the angles is greater than 180. All right, and then the last three kinds of triangles to know would be an equilateral triangle, and that's a triangle that has 3 congruent sides and 3 congruent angles that you would see marked like this. Then you have your isosceles triangle, where only 2 of the sides are equal and 2 of the angles are equal. Then you have your scalene triangle, where none of the sides are equal and none of the angles are equal. All right, so you only had one practice problem to do. I know the notes were a little bit longer, a lot of writing to do. So thanks for bearing with me there and copying them all down. And we're going to review this stuff tomorrow. Make sure you guys got it down. All right, have a good night. Bye.